So, over the last 2 weeks now, I have been hard at work changing how Thrall generates dungeons. And I think I've come up with something pretty cool, and I want to share it. So, previously, how Thrall would generate a dungeon is that it would have a collection of maps, and they were all. Basically, I would have full size, 50 by 50 parallax maps, and I would have 3 times as many maps as there would be floors in a dungeon. So, for example, if a dungeon had 15 floors, 5 floors, I would have 15 maps. And how the game would randomly generate dungeons is it would take 5 of those maps at random, put them in a random order, and then basically set some variables that would semi-randomly determine where the exit would be in that floor, which chests would generate, and which enemies would generate. But if you went through the dungeon a second time, there's a chance that you could come across the same map again. I've now changed that. And I'm going to start just by kind of explaining why I changed that, and it comes down to the scope of this game. Because ultimately, by the end of this, I'm probably going to have close to around 25 dungeons that the player will get access to. You might not necessarily get all of them in one playthrough. You may need to go back on a second playthrough and make a different decision to get access to all the dungeons. But the idea is that you'd have about 25 dungeons, and the depth of them would increase based on how far you were in the story. And when I really did the math on how many maps I would need to create just to create 25 dungeons, it was around 1,200 maps. And I was taking on average about 2 to 3 hours per map to make these. So I was basically setting myself up to do nothing but maps for the next 3 to 5 years, working 2 to 3 hours a day nonstop. I was already getting burnt out, and yeah, it just wasn't sustainable. So something had to give, something had to change. I did not want to reduce the scale of the game. I wanted to keep the same number of dungeons and the same kind of mechanics. I also didn't want to outsource and recruit additional scripters and people to help me, and coders and mappers, because for one, I'm not planning on selling this game, and so any financial investment would come out of pocket, and I wouldn't see any return on that. Or I'd have to find people willing to work for free, and the problem with that is, one, I feel like people should be compensated for their work, but for another, when you do find somebody that's willing to work on your game for free, they're typically not going to be as reliable or as consistent as you would need them to be. And consistency is the other thing. They're likely not going to have the same mapping style as you. You can maybe teach them your mapping style, but it's not going to have the same result. So the alternative to that is find a way to procedurally generate dungeons using parallax maps. And that's what I found out how to do. And I'm going to show you the final result, and then I'm going to show you how I did this. This is quote-unquote procedural dungeon generation. I don't really know if you can actually call it that, but I don't know what else to call it. So I'm going to show you an example of a procedurally generated dungeon in this game. This is still in early development, so it's going to have some repetition, but you'll see what I mean. So let's go to the Bloodstone Mine here. Okay, here we are. This dungeon, this map, was completely rendered in Engine. I did not create this in an editor, or at least not in its entirety. And I'm going to show you just kind of what this all looks like. So we've got our overlays, we've got our light maps and shadow maps, we have an exit randomly placed, enemies randomly placed, we have item bags randomly scattered around, there's likely a few chests kicking around here as well. If I can't find one right away, I'll just go to the next floor and we'll kind of see what we can find. And on the second floor, we've spawned in the same room as a chest. So the chests are scattered about randomly as well. and the dungeon layout and the map was completely generated in Engine. So how did I manage to do this? Well, you may have kind of already been able to pick up on it, and if you can't, I will point it out here. So look at this little room that I'm standing in here. We've got like this track here that leads down. We've got a box with a lamp on it to the right there. We've got this jar and this barrel. Now look at the room over here. It's the same. So the way that this game, quote-unquote, procedurally generates dungeons is that I have a series of rooms that I've done in an image editor, which allows me full control over what each room actually looks like. And the game basically takes those rooms and it randomly connects them together and patches them together and splices them together. And then it runs checks to make sure that they are actually valid and connected, and outputs it as one final completed map. So how's this possible? I'm going to show you. And actually, oh, you know what? Before I show you the script and the actual code involved for this, I'm going to show you a simplified example. I have one set up and ready to go here. So if I just warp into that room, this is a simplified version of it. It's the exact same concept, but basically it just has a series of rooms that have been done in an image editor, spliced them together, randomly scattered the events, set the player, and created a parallax mapped random dungeon. So I want to show you how this works. There's a couple of kind of cool things that I need to show you to do that. So this is the entire script. It's not even 500 lines of code. And it's kind of difficult to read on its own unless you know what it does. But basically, I'll actually show you. So what I've got this module set up here, but basically what the script itself does is that when you load into a room ID, it will immediately generate a dungeon in that room. And I have some tile data set up. This is actually just for testing. This is the actual legitimate tiles. And I maybe will show you what it's like without the with just the test tiles. But basically what this does is it reads the data from the room that you just loaded into. And then what it will do is it will actually establish a layout, and how it does that is it reads room rules and cell rules. So I'll just kind of give you an example. Let's open up MS Paint. Why not? So an example of a room rule would be basically the rooms that can spawn adjacent to the room that just previously generated. Now, what does that look like? So let's say you've got... I'm not good with MS Paint, but bear with me. That didn't quite work the way I wanted to. Okay, let me try this again. 1, 2, 3, 4. Okay, so let's say this is your dungeon. How this game works is that it generates 12 rooms in a 4x3 pattern. It starts from the top left, works its way to the right, and then drops back down to here and keeps working its way left to right, top to bottom. So if it generates a room here and it says there's an exit here and an exit here, it first generates a room based on the cell rule. So this first cell has only a series of rooms that can be generated. It can have an exit to the right, down, or one or the other. But it can't have any exits out those sides. So let's say it generates an exit here and here. It goes to the next room and it says, okay, what are the valid rooms that can generate in this cell? Well, it can have an exit here, here, or here. But based on the previous room's room rule, it has to have an exit leading into that room. So it's going to generate a room. It says, say it does that and then that. Then it goes to the next one. Okay, we're going to have, let's say, oops, too far. Let's say it generates a room like that, and then this room here. Now we're into a new cell. Again, this room can only generate exits to the left and down, but it's sealed off on the left, so it can only generate an exit down. And then it basically goes through and it puts together rooms like so. What's the problem with that, though? Well, there is one problem. It works as far as, okay, it's going to go through the entire room. It's going to figure out what rooms can actually generate in what order. The letters identify a configuration for the room. So, for example, A has an exit top, bottom, left, and right. C has an exit top, bottom, and right, but no left, etc., etc. And there are 26, technically 27 different configurations that include every possible way that a room can generate. It basically puts those rooms together in a random order as long as it follows those rules. But there is a problem with that. What happens when you, the player, spawn into a room like up here, and all these rooms are connected, but it's not in any way connected to these rooms? Well, all these rooms are connected, and all these rooms are connected, but they are not... there is an isolated section of the dungeon here. What if the player spawns in here, but the exit spawns in here? It's going to be impossible to reach that. So what I did was I set up, first off, a fail-safe layout in case it tries to generate a room too many times and fails, but also a validation key. So this is where it's actually determining all the room rules and setting up the collision between each room. But what I did was to validate the map, I actually have this validation key. The first room is always going to be valid, and then every other room after that is invalid. And what you're essentially doing is you're going through the entire layout of the dungeon and validating any room that is connected. And it cycles through this, it cycles through every room for each room that you have. So it cycles through the dungeon basically the size of the dungeon squared, which actually isn't that bad, but basically what it does is it will validate every single room in the dungeon, and if it generates a valid room, it will break out of that loop and proceed with actually creating the dungeon. If it does not, it will go through and it will generate a new layout. So you can end up in some situations where the load times could be a little bit long. I think the longest it could extend to is about half a second, so it's not atrocious, but there you can end up with some longer load times, but it's not too bad. The next thing it does is that it'll actually make sure that you have no less than 6 rooms, and I think it's actually 7. Yeah, no less than 7 rooms. And if you do have less than 7 rooms, it will find one that is just a corridor, not a room, and I'll show you what I mean here. So these are the image files in the sample dungeon that I had. So these are all the rooms, but these are all corridors. You can't spawn into a corridor. Nothing can spawn into a corridor. You can only spawn into rooms. So if you have less than 7, it will go through the dungeon, and as soon as it finds a corridor, it will convert it to a corresponding room. And that's basically how it works. And then once it's done that, that's when it actually will splice together the map. And this uses block transfers like I showed in my previous video. It basically takes the parallax, like the base ground layer that this script typically uses to generate the image that the player would actually be walking on. And it caches that, it caches the overlay, it caches the light and the shadow overlays, and then it will actually go through those rooms and do block transfers to splice together the maps. Now, how does it actually find the file that you're doing that? Well, what it actually does is it will actually figure out what the room code is, and it will find every file in the folder that has that room code, and it will randomly select one and then use that to create the overlay. There is a fair bit of repetition that can happen, and to completely eliminate that, what you would need to do is remove the room from the list of usable rooms once you have selected that once. But you would need to have a minimum of 100 different rooms with specific configurations. I'm not going to go into that right now. Basically to make sure that you always have a room that you can choose from. But yeah, there would have to be about a minimum of 100 rooms. Right now I only have 26, but I'm also having duplicate rooms in the same dungeon floor. At the same time, how does collision get determined? Well, that is actually kind of a little bit of ingenuity on my part, is that I figured out that I can just read the image file name that it's taking to generate that room, and then I can actually split it into its individual characters, read those characters, and change the map data and change the tile data of the coordinates based on that character. So the file name is actually a series. It's first the letter determining the room configuration, and then a series of numbers that actually determine the collision. So 0 indicates that there is, it's impassable. 3 means that you can pass through there, but nothing can spawn there. A 4 means that you can pass through there and either a player or an enemy can spawn there, or a mission objective. And then a 2 indicates that a chest can spawn there. And what that does is it basically makes it so that I can set each room to have one spawn point for either a player or an enemy, so you never spawn into the same room as an enemy. And you can only ever have one chest per room, and I can decide where I want those placed. In any other situation, it'll just skip, and then it will basically construct a room with that collision, with that layout. Then it will actually set the player and the events based on those tiles. Just creates an array with all the tiles that it can potentially spawn in, selects a random one, and places the player and the chest there. And that's it. That's honestly it. I have, in the Bloodstone Mine here, which I'm recreating, these are all the rooms that you can spawn into, and all the potential corridors. I will show you what those look like with the test tiles enabled, just to give you a better example of that. Where is that line of code? There it is. Okay, so I'm going to comment out these, and these are the tiles that are now going to be used. And what this will do is it will actually spawn me into a dungeon, and it will show all the different spawn points and collision, just to give you a clear example of what I'm talking about here. I'm going to start with the sample map, and then I'll go into the Bloodstone Mine to show you it in action. So with the sample map, everything that is purple is a spawn point for a player or an enemy. Every tile that is yellow is a spawn point for a chest. Any tile that's blue, you can walk through, but nothing will spawn in there, so you can't get things spawning in a corridor or blocking access. And then green is passable, and you can get things like item bags, exits, other certain random events. And the thing is, I can create, it's not like that, the exit can spawn on a green tile. And the thing is, I can set up other tiles with specific rules for specific events in later dungeons if I want to. In the Bloodstone Mine, it looks a little janky, but it's just for testing purposes. It makes it just a lot easier to determine the collision. Okay, so we got a bit of a longer load time there, but here we are. It spawned in on a purple tile. There's a yellow tile where a chest can spawn here, but one didn't. All the blue tiles, nothing will spawn there so that it doesn't create any weird visual glitches or block progress. And here we go. So we got a gold chest spawning here, and a red chest with gold trim spawning on this yellow tile. And then the exit can literally spawn on any green tile in this map, so you have no idea where the exit's going to be, even if you made the bloody game. Yeah. And that is procedural dungeon generation using Parallax maps in RPG Maker VX. This took probably about 2 weeks to put together. So honestly, not that long, all things considered. But what this is going to do, okay, so here's an example. This is a corridor. So it's just a room that you pass through, nothing's going to spawn through, so all the tiles are blue. Same with this one here, and you can actually sometimes get these really long, winding corridors that lead to, basically just lead to ring you around. but every branch will always end in a room. In one way or another, it will always end in a room. Like so. And so what this is going to do is it's going to massively reduce the scope of this game. I can still have the same number of dungeons, but this time, instead of increasing the number of maps I need to create for each dungeon, all I need to do to create any dungeon in this game is create 100 small, very quick, easy rooms following a very specific configuration that I've already planned out and laid out, so it's going to be easy to follow, easy to plan out. And it can create a nearly infinite number of combinations of maps. And just to show you that I'm not BSing you and that I didn't, create these in the editor beforehand, I'll actually show you the dungeon that it basically spawns you into for this example. Come on, exit full screen. There we go. So when you go to actually access the Bloodstone Mine, it will take you to Dungeon ID 14. Dungeon ID 14 is right here, and that will send you into either Dungeon ID 2 or 3. Map ID, sorry, I should say. Map ID 2 or 3. And map ID 2 is this one here, which is literally just an empty room. There's no parallax assigned to it. Same with 3. It's exactly the same, empty room. And basically what the game is doing is it's alternating between these two rooms so that it can randomly scatter events and it doesn't have any weird kind of reloading errors where it's got the same stuff in the same spot. And yeah, that's it. That's it. It's maybe not necessarily procedural dungeon generation in the sense of like this, where it just literally randomly constructs a room with tiles and stuff like that, and it's a totally random layout, but it is procedural in the sense of, think like Diablo. Diablo has predetermined kind of rooms for a lot of their dungeons, but then they're stitched together with procedurally generated tunnels. This is kind of the same way. The rooms are predetermined, and in this case, so are the tunnels, but it just stitches them together in a completely random order where you can have a nearly infinite number of combinations of dungeon floors, and I literally only have 2 rooms, 2 maps for the game for that, and just 26 different rooms that are relatively tiny maps. This takes less than 10 minutes to put together. And the coolest thing about it is that all you need to do to implement a new map is drag an image file into this folder. That's it. And the game will automatically take it and implement it into the game. So that is procedural dungeon generation in RPG Maker VX. I wanted to make this basically as a follow-up to my previous video where I showed how you could have randomized dungeon themes using block transfers in RPG Maker VX. And yes, I know that in VX Ace that feature was already done with the tile swap method. That's not the point. The point is that you can do it. It's not necessarily about whether or not it's the easiest method to do it, but you can. And also block transfers actually give you a lot more control because you can alter out specific parts of a tile set instead of switching out the entire thing. But this is a way of using block transfers to quite literally create an entire procedurally generated dungeon with parallax mapping, which I'm pretty sure VX Ace doesn't do that. I could be wrong. I don't know. I haven't actually used it, but I'm pretty sure that it doesn't. So anyway, that's it. I'm thrilled with this, honestly. It's going to massively reduce the amount of work that I need to do, but still create a pretty high-quality result. And when it's actually fully fleshed out and implemented, you're not going to get any of that repetition of having the same room twice on one floor in a dungeon. It'll have a lot more randomness and a lot more just... Yeah, I don't really know how to describe it, but I'm thrilled with the result. and I wanted to share it. So that's it for this video. Hope you're having a great day, and I will see you next time.